So student, today I'm going to tell you about the refraction by spherical lenses. You see, you might have seen watchmakers using a small magnifying glass to see tiny parts. Have you ever touched the surface of magnifying glass with your hand? So whenever you touch the magnifying glass with your hand, then you will come to know that both the surface are coming outwards, and the middle side is larger than the other sides. So you you can see this as a oval shape. So is it plane surface or curve? It is a curved surface. Is it thicker in the middle or at the edges? So it is thicker at the edges, and the middle it is what is called thicker, but at the edges it is thinner. The glasses used in spectacles and that by a watchmaker are examples of lenses. So what is lens? How does it bends light rays? We shall discuss this in the sections. So first of all, you see a transparent material bound by two surfaces of which one or both surfaces are spherical forms a lens. So how lens is formed? If the question is said, then you should write this answer, that a transparent material bound by two surfaces of which one or both surfaces are spherical forms a lens. So you see, this is one type of spherical lens from one type of spherical globes. It is from one type of. You see, there is two types of spherical globes. This is one type of spherical globes, and this is another type of spherical globes. Okay, this is one type, and this is another type. So what's happened? The parts of one sphere is cutted and other is also cutted, and then it is contact each other. Okay, so whenever two parts of two spherical globes, that is spherical globe means this is a globe, glass globes. So the parts is here is what's been cutted, and then these two are fixed each other, then it will form a lens. So this is spherical lens, one type of spherical lens. This is called the convex lens. So what is convex lens? So whenever you see the reflecting surface, this is reflecting surface. If the reflecting surface coming outwards, then this is called convex lens. And you see, there is also one type of lens which is also two types of parts from two globes, glass globes. That is, there is two globes. So whenever we cut one parts from these globes and other parts from these globes and fix each other, then it will form a lens. If the reflecting surface is going inwards in both the sides, then it is called the concave lens. You see, in the midst of the lens, it is thinner, but in the outside it is thicker. Okay, so such type of lens is called concave lens, and this is convex lens. So we now come to know that what is convex lens and what is concave lens. Now you see, as this lens is associated with two globes, circular globes, that is why this globe has one center of curvatures, and this also one center of curvatures. Okay, that is why we get two center of curvature, which is here denoted as twice of f1 and twice of f2. You see, twice of f1 and twice of f2 is nothing but the center of curvature of two globes. That is, these globes has the center of curvature twice f1, and in these globes the center of curvature is called as twice f2. Here this is not a center of curvature, called as center of curvature as in the mirror, but in the lens it is called as twice of f1 and twice of f2. Why it is called twice of f1 and twice of f2? You see, the distance from the focus is double to its center of curvature. So we do not write here center of curvature, we write it as twice of f1. That is that this distance is double to the focal length. That is why it is called twice of f1. Likewise, in case of concave lens also, we can found two twice f1 and twice f2. Okay, f1 and f2. But in case of concave lens, as the image is formed in the left side, that is why the f2 and twice f2 is not considered. Only twice f1 and f1 is considered, because in case of concave lens, what's happened, the image form is always in the left side of the lens. That is why likewise the convex lens f2 and twice f2 is not considered in this concave lens. Okay, next, I think you come to know how lens is formed. Again, I repeat it. So lens is formed by two parts of different two globes. Okay, then what's been one part of transparent glass globes is fixed with the other parts, then it will form lens. If the reflecting surface is coming outwards, then this is called as convex. If the reflecting surface is curved inwards, then it is called concave lens. This is convex lens and this is concave lens. So now read the next passage. That is, a transparent material bound by two surfaces of which one or both surfaces are spherical forms a lens. So how lens is formed? So you should write the question first. How lens is formed? So the answer will be, a transparent material bound by two surfaces of which one or both surfaces are spherical forms a lens. So this will be the answer. Next, this means that a lens is bound by at least one spherical surface in which lenses the other surface would be plane. In some lens, what's happened, one surface is curved but the other surface is not curved, it is plane. Such type of lens also we'll able to found in the next sessions. But in this chapters, we should also discuss about the convex and concave. Only the convex and concave characters are found here, but the other lenses are not discussed here. That is why we must emphasize on the convex and concave lens. Okay, so a lens may have two spherical surfaces bulging outwards. Here, dear spherical surface bulging outwards. Okay, such a lens is called a double concave lens. Why this is called double convex lens? Because you see, so both there is two surfaces, one here is two, that is why it is called double convex lens. It is simply called a convex lens. This is not called as double convex lens, simply called as convex lens. It is thicker at the middle as compared to the edges. You see, in the edges it is not thicker, it is thinner, but in the middle it is thicker. Okay, so this is one of the characters of convex lens. So you should remind it while comparing convex and concave lens in its characters or in its forms. So it is simply called a convex lens. Then convex lens converges light rays as shown in figure 10.12. Here you see. So whenever converge means whenever the reflected light ray meets at one point, this is called converging characters. So due to the converging character, what's happened, we can see the tiny particles bigger as magnified with the help of a convex lens. Okay, so what's happened, it converges at a point. So you see, whenever we keep an object in this place, then what's happened, the light ray will go away. After that it will form parallel. If we look from this point, then we will see this object as a very magnified form. So very larger size, as a very larger size whenever we point it at the focus point of this lens. That is why whenever we use the magnifying lens, we have to place the object at its focus. Then we can able to see the object in a very large size. Okay, so next you see convex lens converge light rays as shown in figure 10.12. Converge means after reflection it will meet at a point. This is called converging. So what's happened in case of concave lens? It diverges. So after reflection, if the reflected light ray go away from each other, then it is called diverging. So in case of what's happened in case of concave lens, the reflected light ray will diverge, and in case of convex lens, after reflection the reflected light ray will diverge. Okay, sorry, converge to a point. So this is converging. This is also called as converging lens, and this is also called as concave or diverging lens. So remind the name of this lens also. This is called diverging and this is called converging lens also. Next, hence convex lenses are also called converging lenses. Similarly, a double concave lens is bounded by two spherical surfaces curved inwards. You see the spherical surface is curved inwards in case of concave lens. Okay, it is thicker at the edges than at the middle. You see this is thicker portions at the edges, but in the middle portion it is very thin. Okay, so such lenses diverge light rays as shown in figure 10.1. It diverges light after reflections. It is go away from each other. So whenever light ray goes away from each other, then this is called the diverging. Okay, so diverging is done mainly by the concave lens. Such lenses are also called diverging lenses. This is also called diverging lenses because it diverges the light ray after reflections. A double concave lens is simply called a concave lens. So this is called concave lens. So now you should write a question and answer this from your textbook. That is, what is concave and convex lens? What is concave and convex lens? Write its characters. Write its characters. Character means whether it is converging or diverging. What's happen whenever parallel light ray incides on it after reflection? What will happen? Whether it will diverge, whether it will converge. Okay, this is the characters, and also the character includes the thicker and thinner portion. That is, in case of convex lens, we see that in the middle portion is thicker, but the edges are thinner. But in case of concave lens, the edges are thicker, but the middle portion is thinner. So this will also included in the characteristics of the lenses. Now, a lens, either a convex lens or a concave lens, has two spherical surfaces. You see, there are two spherical surfaces. This is one, this is one. Why is it called spherical surfaces? Because it originates from a sphere. That is why this surface originates from this sphere. Okay, and this surface originates from this sphere. That is why this is called spherical surfaces. So spherical surfaces, each of these surfaces forms a part of sphere. The center of these spheres are called center of curvature of the lens. So I have already mentioned you that this is one sphere, the center of which is called the center of the sphere. Okay, here also there is two sphere. That is why we will get there is two sphere. Okay, so that is why we will get two centers of curvatures. Next, since there are two centers of curvature, we may represent them as C1 and C2. An imaginary straight line passing through the two centers of curvatures of a lens is called the principal axis. So about the principal axis, I mentioned it in the class mirror. In case of mirror, I have told you that what is principal axis, what is center of curvatures. So I'd not like to mention it again. So remind what is principal axis. Actually, you see what's been the line which goes along the center of curvature, that is twice f1 and through the optical centers. Okay, this is called the principal axis. Next, we may represent so an imaginary straight line passing through the two centers of curvature of a lens is called its principal axis. Thus, central point of lens is its optical center. It is also called as optical centers. Why it is called optical centers? Because you see, in case of lens, the reflection of light ray occurs. That is why it is called. It is also called as opticals. Okay, so opticals means it is derived from optics means light. So this is also called opticals because it related with the reflection of light. That is why it is also mentioned as optical centers. So optical center means the center of that curvatures. Okay, it is also called as optical centers. Next, you see, usually represented by the letter O. Optical center is also represented by O, which is found amidst the lens. Okay, this is optical center which is found amidst the lens. Actually, the optical center has one most interesting character is that whenever light ray goes through the optical centers, it will not deviate after reflections. Okay, so there is one question you should write it, that what is the significance of optical centers? This question is a common question. What is the significance or characteristics of an optical centers of lens? What is the characteristics of optical centers? Simply write these questions and answer. What will be the answers? The light ray which coming through the optical centers will not deviate after reflection. This is the answers. Next, you see, a ray of light through the optical centers of a lens passes without suffering any deviation. Deviation means it will not go in a different way. It will go in the same way. That is why it is not deviated. Deviated means go away from its original directions. So the effective diameter of the circular outline of a spherical lens is called its apertures. So what will be the apertures? So all these reflecting surface is called apertures. From here, M, N, this is apertures. Here it is apertures. So apertures mean the total reflecting surface of the lens is called apertures. I have already mentioned it in the mirror also. There is apertures, and in the lenses also the MN this length is totally called as aperture, because all these surfaces will reflect light through the lens. Next, we shall confine our discussion in the chapter to such lenses whose aperture is much less than its radius of curvature, and the two centers of curvatures are equidistant from the optical centers O. Such lenses are called thin lenses with small apertures. What happens when parallel rays of light are incident on lens? Let us do an activity to understand this. So you see, so whenever parallel light ray incides on a lens, then what's happen? In case of convex lens, it will meet at a point. This is principal axis. These are the light ray inside on it. So after refraction, what's happen? The reflected light ray will intersect at a point in the principal axis. But in case of concave lens, what's happen? The light ray incides parallel to the principal axis. This is parallel principal axis. This is the parallel light ray incides on it. After reflection, what will happen? This will go away from the principal axis. This is principal axis. This is reflected light ray. So if it goes away, then what happen? The line will go away from this. You see, it will go away from each other. This is the characteristic of these two lenses also. So whenever you say, I repeat, whenever the light ray incides parallel to the principal axis on a convex lens, after refraction it will meet at a point on the principal axis. But in case of concave lens, what's happen? The light ray incides parallel to the principal axis. After refraction will go away from the principal axis. Okay, so this is the significant characters of concave and convex lens. So you should remind it. Next, you see, here is one activity. Activity 10.11. So you see, hold a convex lens in your hand, direct it towards the sun. Focus the light from the sun on a sheet of paper. Obtain a sharp, bright image of the sun. Hold the paper and the lens in the same position for a while. Keep observing the paper. What happened? Why? Recall your experience in activity 10.2. Actually, you see what's happened. Whenever you keep the magnifying lens facing sun, and what's happened? The sun ray will incide parallel to the principal axis of the lens, magnifying lens. After refraction, what's happened? All the sun ray will meet at a point on the focus of the convex lens. So what happened at that point? Due to the congregation of different light ray coming parallel inside on the lens, as they meet at one point together, that is why at that point there will be a high temperatures. Due to the high temperature, what happened? The sheet of paper will burn. Okay, the sheet of paper will burn due to the excessive heat which is produced due to the intersection of different light ray at a point. Okay, so this is happens only in case of convex lens also. So you should remember that you should place the paper at the focus of the convex lens, because you see at the focus, only in the focus point of the convex lens the reflected light ray will intersect. If we place the paper on the other point rather than the focus point, then you will not see that characters, that is, it will not burn easily. Okay, that is why you should place it on the focus of the convex lens. Next, here we see the paper begins to burn, producing smoke. Okay, it will burn. It may even catch fire after a while. Why it will catch fire? Because you see, whenever any substance get the ignition point, then after that it will catch fire. To catch fire, it would have some oxygens also. The oxygen will be supplied from the atmosphere, and as it attains the ignition point, then what happens? The paper begins to catch fire. So the light from the sun constitute parallel light ray of light. These rays are covered by the lens as sharp bright spot form on the paper. So spot will be the focus point of the convex lens. In fact, the bright spot you got on the paper is a real image of the sun. Why is it real image? Because you see what's happened you see in this experiment, this is convex lens, this is sun ray in such parallel, then after reflection it will meet at a point. So as the reflected light ray intersect at a point really, not partially, then what happen? In this point, a inverted image will form. Okay, this is called real image. So remind how real image is formed in case of mirror. Okay, so whenever light ray after reflection intersect at a point really, then it will form a image which looks to be inverted, and it is a real image. So this is one type of real image which is formed in the convex lens. The concentration of sunlight at a point generated heat. This caused the paper to burn. So to burn, we have to get the ignition point also. Okay. So whenever we get heat, then it is not able to catch fire, because you see, you should get the ignition point of that substance, that is then it will ready to burn. Okay, so first of all it will get the ignition point so that it can be burned easily. So now we shall consider rays of light parallel to the principal axis of a lens. What happens when you pass such rays of light through a lens? This is illustrated for a convex lens and for a concave lens. So what happens whenever the parallel light ray incides on a concave lens, it will diverge from one ray to ray from another. You see, in case of concave, what happens whenever light ray incides, the reflected light ray will go away from each other. That is why it will diverge. But in case of convex mirror, after reflection, it will meet at a point. So there is a first difference between the convex and concave lens. Now observe 10.1 carefully. Several rays of light parallel to the principal axis are falling on a convex lens. These rays are reflected from the lens are converging to a point on the principal axis. Okay, this point on the spherical axis is called the principal focus of the lens. So if you are asked to write the principal focus of convex lens, then what will be your answers? The parallel light ray after reflection intersect at a point on the principal axis. This point is called the principal focus of the convex lens. Okay, so what will be the principal focus of the convex lens? I again see. So this is parallel light ray which incides on a convex lens. After reflection, it will intersect at a point on the principal axis. This is the principal axis. Okay, that is why this point is called the focus point of the convex lens. Next, this point is principal axis called the focus point of the convex lens. Let us see now the action of a concave lens. So in case of concave lens, you see, observe figure 10.12. Be carefully. Several rays of light parallel to the principal axis are falling on a concave lens. These rays after reflection from the lens are appearing to diverge from a point on the principal axis. This point on the principal axis is called the principal focus of the concave lens. So principal focus, what is principal focus of a concave lens? You see here, the light ray insides on the concave lens parallel to the principal axis. After refractions, if we extend the refracted light, you see the refracted light ray goes on these directions, it will not meet, because you see this goes diverging from each other. That is why it will not meet at any point. But if we extend this reflected light ray backwards, then it will intersect at a point on the principal axis. This point is called the principal focus of a concave lens. Okay. Now, next, if we pass parallel ray from the opposite surface of the lens, you get another principal focus on the opposite side. Letter F means focus point, is usually used to represent principal focus. However, a lens has two principal focus. Okay, I have already mentioned you that there is two principal. The word is foci because the plural of focus is foci. So they are represented by F1 and F2. Here you see F1 and F2. This is F1, this is F2. But in case of concave, I have already mentioned you that the F2 is not considered because all the images are from here. Okay. In case of convex lens, what happens, you will come to know that the images from both the sides. If the image is formed on the right side, then this is called the real image. If the image is formed on left side, then this is called the virtual image. So that is why F1 and F2 is considered in case of convex lens. But in case of concave lens, what's happen? In case of concave lens, what's happen? The image form is always to the left side. But in case of convex, what's happen? The image form is both on the both side. If the image is formed on the right side of the lens, this is called the real image or positive image, and if it is formed in this direction, this is called virtual or negative image. But in case of concave, what's happened? All the images are formed on the left side. Okay, this is always virtual and erect. Okay, next, you see. That is why this is called the lenses have two types of focus, that is F1 and F2. So this letter is used to represent the focal length. How can you find the focal length of a convex lens? Recall the activity 10.11. In this activity, the distance between the position of the lens and the position of the image of the sun gives the approximate focal length of the lens. So what is the experiment? In this experiment, you see, whenever we put a convex lens, then what's happened? The convex lens will intersect at a point. You see, if this is convex lens and light ray incides parallel to it, then after refraction, it will meet at a point. Okay, meet at a point. So this point is called the focus point of the convex lens. So we can easily find out the focal length or focus point of a convex lens. The focal length is called the distance between the focus point and the lens is called the focal length, which is denoted as small f. But the focus point is denoted by capital F. Okay, so how can we find out the focus point of a convex lens? So if we put a convex lens facing sun, then what's happened? The sunlight will incide parallel to the convex lens. Then what will happen? It will meet at a point. This point is called the focus point of the convex lens. Okay, next you see. So thus we can find out the focal length of a convex lens. Next, image formation by lenses. How images form? So lenses form image by replacing light. How do lenses form images. What is their nature? Let us study this for a convex lens first. Actually, you see, nature means whenever you are asked to write the nature of image, then you just write whether it virtual or real. Okay, all virtual images are real and all real images are inverted. So whenever you see you are asked to write the nature of the image, then you should write that the image form is real or virtual, the real image and the virtual image. This is called the nature. If the image form is positive, after calculation you get the positive p as positive, then what's happen? This is considered as real image. So real image will always be set as inverted, but in case of virtual image it will always be found as p negative. Okay, then this is considered as virtual image. Virtual image is always found as erect. Okay, so thanks for today. I will meet you again in the next class. Hope you will understand. You will repeat all the question answers, and if there is any doubt, and you can ask me on my WhatsApp number. Thanks for today.